BIT353 Assessment 2 Network Architecture and Protocols made by 1516467. Hello everyone, welcome to BIT353 Assessment 2, and today's topic is trial engineering technologies, exploring the business benefits of big data, IoT, and cross services. So here are the table of contents. First, I will introduce the three technologies, and after that, the benefits brought to the businesses and implementation of three technologies on the virtual machines. After that, I will tell you the Azure Lab 3 experiments, and then come to the final summaries and development and outlook part. So here I introduce those three technologies. So big data covers the large-scale structured and unstructured information generated from individuals, devices, and systems. By analyzing this information, companies can gain in-depth insights, decision-making basis to drive business development and innovation. The Internet of Things forms an interconnected network by connecting the physical devices embedded with sensors, software, and connectivity, enabling enterprises to connect and analyze the device data in real time and optimize the process, improve efficiency, and improve smarter products and services. Provide smart products and services. Cloud service provide on-demand access to a pool shared computing resources over the internet, enabling business to flexibility, expand and shrink infrastructure and save costs. And computer services also provide highly reliable data storage and processing capabilities to a large extent. The above is a simple explanation of three technologies. Next, I will give more specific analysis. So in this fast-paced digital age, business must adapt to remain competitive, so it becomes a more important part for enterprise development. This service can no doubt help companies better manage and analyze data, improve production efficiency, reduce costs, enhance security, and improve customers' certification and more. So in next session, we'll explore why enterprises should consider adding big data, IoT, and cross services into their operations. So in big data disrupted computing can achieve low latency using verticalization, partitioning, aggregation, isolating resources of any scale and dynamically changing it, thereby minimizing the latency of any scale. Through the cloud enables affordable storage and computing with minimal human effort. So you can see as example from the Apache Hadoop in IBM, and also in Internet of Things. Through this technology, enterprises can connect devices into the internet and monitor status and operation of devices in real time. This information can help companies better predict equipment failures, improve equipment utilization, and reduce maintenance costs. And this is from a funny website, and there will be many interesting articles about it. And after that will be the cloud services. So the cloud services can help businesses to better manage and storage data. Through the cloud services, enterprise can store data in the cloud and access this data anytime and anywhere. This data can help companies better understand the information such as customer needs and the marketing trends, and make better strategic decisions. And next, I will present the implementation of the technology in vertical experiment environment and networks. Alright, hi everyone. Here are some three techniques used on the real life. So in cloud computing, we are using like Google Cloud as an example, because we have so many advantages, so we use that as an example. So after we have set up for the Google Cloud, and you can see the interface like this one. project and API and resources. It require all like backend like databases, SQL, storage, and app engines, things like that. And they can also have platform status monitoring. That's all inside. So it's really convenient for like small companies like to start with, and easier to manage with like managing tool, monitoring tool, storage tool. As you can see here, we go storage. And since I have not created any things, so we can see that. But like in monitoring, we can see like from which time the access is the highest and which time is the lowest. So it's very easy for beginners to learn in cloud computing. And here are also like marketplaces for like owners to manage the project. You can also use WordExpress and MongoDB as well, and those kind of styles for managers to do and qualified for all kind of forms. And that pretty much is the cloud computing in real life. So next, after we introduce the cloud computing, next it's time to introduce to you the IoT system. So the IoT, we use the MQTT is a famous one. So in this experiment, I used MTTX to introduce to you. So MTTX docs adapts the cross-platform technology to send and receive messages in interactive messages and interactive forms of the message chat, allowing multiple client connections and establish the same time, freely switching to communicate with each other. It has better interactivity and great improvements and efficiency of MQTT development and testing as well. See here, we can type out my name and then just simple connect. And as you see, it's already connected. So, and you can also like send the messages like topic and like new subscription, and also like new connections, and also script. You can type script here. As you can see here, the input like hello, and also logs to like record everything. And here, and that's pretty much it. And you can also learn from the guidance to learn MQTT and also like MQTT breaker. And that's pretty much is the IoT, MQTT, and about in the IoT system in real life. Okay, after we discussing the IoT, it's time for Hadoop database. Since it's running on the virtual machine, and it's a bit causing huge time and also space to introduce. So I just using the previous I have done in FMP, the work I have done in there. And it's basically like installing the Hadoop and Spark and also Hive to do the database science analysis. And first, like step by step, by changing the environment like Java home, and also test like after we type JPS, you can see here like name node, the node manager, JPS, resource manager, and name node and secondary name node. And after that, you will find there will be a dashboard, and after you link with the server, and there will be a dashboard and overview summary and Hadoop applications and all these kind of things like you can like have access on, and that'll apply on the databases and so on. So pretty much that is pretty much we use big data in real life. Okay, well, everyone, this is the first experiment called Cisco UCS platform emulator, and this is about the Cisco platform is a powerful and highly integrated data center solution that can help enterprises to improve efficiency, reduce cost, and support rapid business development. And you can see we have already opened the managed PC, router, and also the platform itself. And you can see in the line here, you can input A for IP addresses. And you can see here is 10.5.0.20, and after you can connect in the website itself. And after we connect, we can see this is pretty much what it will look like. It has 3 CCs and 2 interconnect and 2 FPX and several servers. So this one is uses Cisco network knowledge to simulate data center network well and supporting fast data transmission in real-time application requirements. Through the integration and computing nodes and virtualization technology, powerful computing capabilities and flexible resource allocation can be achieved to improve the performance and the efficiency of applications. So you can see this is like the basic network look like, and you can see the details out of everything. You can also like status details, yeah, and to see every like information you needed. And it improves the centralized management and monitoring functions to simplify the work of the data center, and it also supports flexible expansion of computing and storage resources according to business needs and rely on on-demand allocation and the dynamic adjustment. And you can pretty much see everything in storage and make some changes. Admin, yeah, pretty much that's it. And you can also make comments on this one to reboot the VM or log out and things like that. Shut down some machines and things like that. Right, it's time for me to introducing the second lab, which is Dell EMC one file system. And this system is very parallel distributed network file system that is foundation of scanned out storage platform. And you can see here are 4 machines. One is management and one is staff, and also routers and the platform itself. So after we open the platform and router, we can also simply connect to the dashboard and using the IP addresses and also the name and password provided. And we can see the dashboard. And this platform is ensure data security and reliability and prevent data losses. This provides a unified management interface and automated management functions to simplify congestion monitoring and maintenance of storage resources. And also supports multiple computing nodes and access to share storage data at the same time, releasing efficient data sharing and collaboration. And here I have changing, like in this platform, you can change in different kind of settings. Like you can change the IP address pool, and also you can change a lot of things to see whether it's to meet your requirements and monitoring behaviors. And you can see access, like file filter. You can see many kind of things, and you can also ping, like ping I31, and it's like have responses. And also you can see membership, like file system, and you can changing some like changing some passwords and things like that. And there are also two experiments, which is OpenVPN and FreePBX. I have done this before. And OpenVPN is a secure remote access connections, and VoIP is FreePBX. It's like real-time voice communication and telephone services through the voice over the IP technology. So I have done actual work is like lab 5, 6, and 7. It's about Zen server. First, like I implemented ISO document Zen server, and after that I implemented, as you can see the address here. And after that I have access to log into the IP addresses in this addresses, and then download this one. It's called Zen Center installer, and after that you have like connected with the Zen server, and you can like monitor and have data access and analyze data as well. Okay, now it's time to the conclusion part. So in conclusion, integrating big data, IoT, and cross services can have revolutionized the way businesses operate to thrive in the digital age. These services provide businesses with tools and harness the power of data, optimizing processing, improve customer experiences. By adopting these technologies, businesses can gain competitive advantages, drive innovation, and future-proof their operations. So let us embrace and the powerful trial of big data, IoT, and cross services, and unlock the enormous potential they hold for our businesses and our collective future. So after that, we'll talk about the future and the outlook. Of this above mentioned, we are not only need to understand the actual impact on the enterprise, but also look forward for their potential development and in the future. We can take advantage of big data technologies, which can sharing across industries and organizations, and collaborate and have more strength collaboration. By sharing data and experiences together, we can tackle complex challenges with great success. So at the same time, in IoT, we will witness the interconnection of more products and more powerful internet network, and achieved more efficient energy utilization and environmental monitoring. The Internet of Things will be a key to divert the digital transformation and smart living. Finally, we can use cloud computing to achieve more efficient energy utilization and more accurate network environmental monitoring, and also authorization, encryption, and access control, and also protect the policies of our user data. So in the future, big data, IoT, and cross services will continue to shape our business in real life, and we should maintain keen insight, keep up with the pace of technological development, and also apply these technologies to innovation, optimize business process, and create a better future. Thank you very much for listening. This is the end of the report.